Good day. So today we are to discuss ratio, proportion, and variation. So first up, we have ratio. So if you say ratio, basically the quotient of two numbers or two identities. So we can express a ratio in terms of a fraction. For example, we have that is a over b. So the ratio of a to b. Or we can express it using a column that is a to b. So for example, we are required to determine the ratio of surface area of a sphere to its volume. So what is the equivalent of the volume of a sphere? So we have the volume is equal to 4 pi the radius cube divided by 3. That is the volume. What is the surface area of a sphere? We'll be having a surface area equal to 4 times pi times the square of the radius. We are looking for the radius of the surface area of a sphere to its volume. Basically, if we say ratio, we are just to express the quotient of the two. So we have surface area is to the volume of the sphere. What is our surface area? We have that as 4 pi the radius squared. This is divided by, this is equivalent of the volume. We have that as 4 pi the radius cube. This is divided by 3. So the ratio of the surface area over the volume is the same as, we may cancel 4 pi r squared. So we have a remaining term of radius. We bring 3 to the numerator. This is the same as 3 divided by the radius. So that is the ratio of the surface area to the volume. So that's an example of ratio. Then we have proportion. So proportion, if you say proportion, this is the equation of two identities, or basically the equation of the ratios. So we can have it as A is to B, or A over B is equal to C over D. So we can also express a proportion using column that is the same as A is to B, or A to B. This is A to B is equal to C to D. So we call A and D as the extremes, and we have B and C are as the means. Okay, so let's have an example. For example, we have the proportion that is x to 25 minus x, or x to the quantity 25 minus x is equal to 3 is to 7. So we can have it in terms of a fraction. This is the same as x over 25 minus x is equal to 3 over 7. Then we may perform cross multiplication. So this is the same as 7x. Then 3 multiplied by the quantity 25 minus x. So we have 7x is equal to 3 times 25. This is equal to 75 minus 3x. So for example, we are looking for this problem, for example, we are looking for the value of x. So we have now 7x. This is 7x plus 10x is equal to 75. 7x plus 3x equal to 75. So we have that as 10x is equal to 75. So dividing both sides by 10, we have the value of x as 75 over 10 is 7.5. So this is our example for a proportion. another example. So for example, we have if x is to y, so the 1 is to 2, then what is the equivalent of the quantity 2x plus 3y is to x plus 4y. So let's have it as a fraction. We have the first given proportion. This is x to y is 1 to 2. So this is the same as x over y is basically equal to 1/2 or 1 over 2. That is from the given. So from this problem, so let us express these two terms into a fraction. So we have that as 2x plus 3y. This is divided by the quantity x plus 4y. So equal to, so we are looking for the equivalent, or let us arrange our variable to have the ratio of x and y. So to have that, all we have to do is we have 2x plus 3y divided by we have x plus 4y. So we have to do is multiply the numerator and the denominator by 1 over y. So this is multiplied by 1 over y. I multiplied by 1 over y. As you can see, that is the same as 1. So what will be the result if we are to simplify? So this will be the same as we have 2x over y plus 3y over y is we have this is 3. So divided by, I will be having the equivalent of x over y plus 4y over y is the same as 4. So from the start of our solution, what is the equivalent of x over y? We have that as 1/2. All we have to do is substitute. So this is the same as we have 2. This is now 2 equivalent of x over y is 1/2 plus we have 3. This is divided by x over y is we have 1/2 plus 4. So we may simplify. This is the same as 2 over 2. This 1 plus 3 we have. This is 4 divided by 1/2 plus 4. So we may still simplify the denominator. So we have the equivalent of 2x plus 3y. This is over x plus 4y. So we have that as 4 divided by common denominator will be 2, 1 plus 8. So we have this as 4 divided by 9 over 2, or if you are to simplify, 2 times 4, this is the same as 8 over 9. So the equivalent of 2x plus 3y all over x plus 4y is basically equal to 8 over 9. So this will be our second example for proportion. Next up, we have variation. So if we say variation, it is a mathematical function that relates the value of one variable to the values of other variables. So we have 3 main types. The first one, we have the direct variation. So for example, we have y is directly proportional to the value of x, or we can have it as y varies directly as x. So from proportionality, we can have it in terms of an equation by putting a proportionality constant k. Okay, so k times x, wherein our k is the proportionality constant. So that is our, okay, this is for direct proportion, direct variation, so directly proportional or varies directly. So other than the direct variation, we have the inverse variation. So for inverse variation, for example, we have y is inversely proportional to x. We write it as y is inversely proportional to x. One variable is proportional to the reciprocal of the other variable. So to have it as equation, y, we are placing the proportionality constant multiplied by 1 over x. So this is for inverse variation. So one variable is proportional to the reciprocal of the other. Okay, then we have the last one. This is the joint variation. So let's say z is proportional or directly proportional to the product of x and y. So one variable is proportional to the joint of two other variables. So if we are to convert this terms into equation, z is not equal to putting a proportionality constant multiplied by the product of x and y. So let's have an example for the application of variation. So let's have an example for, or examples for variation. Alright, let's have number 1. So for number 1, n is inversely proportional to the square of x. How do we write that? We have n is inversely proportional to the square of x. So it means n is proportional to the reciprocal of the square of x. So we have how to convert this one to an equation. We have n is equal to, we are placing a proportionality constant multiplied by 1 over x squared. So we have, in the first case, we have x is equal to 2 and n is equal to 50. So we have at x is equal to 2 and n is equal to 50. Since we have now the value of x and n, we can compute for the value of the proportionality constant. So this is, by substitution, we have 50 for the value of n equal to the proportionality constant. This is 1 divided by the value of x is, we have 2 squared. So we having the value of proportionality constant is 50 times 2 squared, that is 4. 50 times 4 is, we have a proportionality constant equal to 200. So the question is, what is n when x is equal to 5? So now we are looking for the value of n if the value of x is equal to 5. So we go back with our equation. That is, n is equal to the proportionality constant multiplied by 1 over x squared. So we are looking for n. What is the value of our proportionality constant? That is 200. This is multiplied by 1 over, the value of x this time is 5 squared. So we have the value of n is not equal to 200 divided by 25. And 200 over 25 is equal to, we have the value of n as 8. This is our first example. Let's have example number 2. So given that w varies directly as the product of x and y and inversely as the square of z. So how do we write the variation? We have as number 2, w varies directly as the product of x and y and so this is a joint variation, and inversely as the square of z. So we have the square of z. So this is our variation. So to have it as equation, we have w is equal to, we are placing a proportionality constant. This is multiplied by x, y divided by the z squared. So we have the first given values. We have w is equal to 4, x is equal to 2, the value of y is equal to 6, and the value of z is equal to 3. So we have w is equal to 4, or So that w is equal to 4 when x is equal to 2, y is equal to 6, and z is equal to 3. So now we are looking for the value of the, or we can now compute for the value of the proportionality constant. Okay, we have that is 4 equal to the proportionality constant. This is multiplied by, what is the value of x? Okay, the value of y is 6. This is divided by the value of z is 3. This is, we have the value as square. So we have now, this is 4 is equal to k. We are to simplify this one. It's the same as 2 times 6. We have that as 12 divided by 9. So we have the value of k as 9 times 4. That is divided by 12. We have it as 36 over 12. So our proportionality constant is simply equal to 3. Okay, so next is on the problem, I find the value of the w when x is equal to 1, and y is equal to 4, and the value of z is now equal to 2. So we are now looking for the value of the w. So from our equation, we have w is equal to proportionality constant multiplied by x, y divided by z squared. All you have to do now is substitute. We have now the value of w, and the value of the proportionality constant is, we have it as 3. This is 3 multiplied by the new value of x, that is 1. The value of y is 4. This is divided by, what is the value of z? We have this as 2 squared. So we have 2 squared as 4. So cancel. So 3 times 1, we have now the value of w as 3. So this will be our answer. So let's have this example. Example number 3. The electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. So we have number 3, R for the, let's say, resistance. Then L as the length. And D for the diameter. So according to the problem, the electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. So you have the resistance is directly proportional to its length, but inversely as the square of its diameter. So the reciprocal of the diameter, square. So to convert these terms into equation, or this proportionality to an equation, we are placing a proportionality constant. K is multiplied by the length divided by the diameter squared. So let's have the given. So initial given, we have the length is equal to 30 meters. If a wire 30 meters long and 0.75 mm, our diameter is equal to 0.75 millimeters. Millimeter has a resistance of 25 ohms. So let's say the resistance equal to 25. This is the symbol for the unit ohms, I think. Yes, omega ohms. So 25 ohms. So find the length of the wire of the same material whose resistance and diameter are 30 ohms and 1.35 mm respectively. So let us first compute the value of the proportionality constant. So we have now the resistance as 25 ohms is equal to the proportionality constant. What is our length? This is 30 meters. Divided by your diameter, we have 0.75 millimeter, and that should be squared. So what is the value or equivalent of the proportionality constant? So we have that as 25 times 0.75 25 times 0.75 squared. And this is divided by 30 meters. So we have it as 15 over 32. What will be the unit if you are to observe? This is ohms, millimeter squared, divided by a meter. That is the unit. Okay, so here we are now looking for the length of the wire. Okay, for the new values. Okay, post resistance. Okay, we have a new value of the resistance as 30 ohms and a diameter of 1.25 millimeters. So we are looking for the length this time. Okay, so what is our initial equation? That is the resistance is equal to the proportionality constant, the length divided by the diameter squared. And we have the resistance as 30 ohms. Equal to, what is our proportionality constant? And we have the resistance is 30 ohms. Equal to, our proportionality constant is, we have that as 15 divided by 32. The unit is ohms, millimeter squared, divided by meter. Multiplied by the length. This is divided by the new value of the diameter is 1.25 millimeters, and this quantity should be squared. If we are to do unit analysis, we may cancel now the ohms, mm squared. So the remaining unit will be the same as a meter. So we can now compute for the length. So this is the same as 30. This is 30. 30 times 1.25 squared. That is divided by 15 over 32. So we have that as 100 meters. That will be our answer.